Welcome to my house. Welcome to the Structure Talk podcast, a production of Structure Tech Home Inspections. My name is Reuben Saltzman. I'm your host, alongside building science geek Tessa Murry. We help home inspectors up their game through education, and we help homeowners to be better stewards of their houses. We've been keeping it real on this podcast since 2019, and we are also the #1 home inspection podcast in the world, according to my mom. Welcome back to the Structure Talk podcast. It has been too long. We've taken a few weeks off. Tessa, good to see you.
Reuben.
What's new?
Good to see you too. I didn't realize that we were taking 3 weeks off until we were, but it's
Until
good to
I
be
kept
back.
canceling calendar events without even telling you.
You know what? It worked out. My life has been a little hectic and busy the last few weeks, so it was actually perfect to have a little break from the podcast, but I am happy to be back.
Okay, why was your life so hectic? Anything you want to share? I'm putting you on the spot now. We didn't talk about this. We don't plan our shows.
We definitely don't. We definitely don't. Well, you know what? I am spending time between Florida and Minnesota now. I'm
Okay.
calling both states kind of, I guess it's like a hybrid living situation. So I'm in Tampa right now, but other times I might be broadcasting from Minnesota. So stay tuned.
Love it. Love it.
Yep.
And
Yep.
we were canceling the show because I was traveling, and I found it does not work well for me to try to record these podcasts in the middle of other things. My mind is just not there.
It's not easy.
Equipment's not there. Yeah. So
Yeah.
And we're gonna have a few more of those coming up in the next couple of months. I'm gonna be traveling a lot. So but it's nice to see you again, and it is sunny and beautiful here in Minnesota. We've got a balmy 50-degree day here or something like that.
Hey, that's a nice day. That's a great day.
It's a great day. It is really nice. Yeah.
I don't want to one-up you, but it's like 78 and sunny here. So
shut up.
Well, pretty soon it'll be like 95 and humid. So
you'll
win every time.
It'll be my turn.
Yeah.
Well,
exactly.
We've got a guest on who's got us both beat on the heat index today. We had RK Bob Brown, also known as just Bob Brown, on our show maybe a month ago or so. No, it was probably about 2 months ago.
I think it was around Christmas time.
Was it? Time flies.
Yeah.
Okay.
It does. Yeah.
Well, we had him on the show to talk about foundation problems and all the crazy stuff that foundation contractors like to come out and sell people all the stuff that they don't really need. And he must have mentioned the term geotechnical engineer about 57 times on that podcast. And since then, I have not even found a good one in our area to refer business to, but he really emphasized the importance of having a geotechnical engineer evaluate this stuff when you got problems with foundations. And so the universe brought us a geotechnical engineer, and we've got someone to interview today. Unfortunately, he's not out of Minnesota, but I've got Michael Simpson on the show today, and he's out of the Phoenix area. Michael, how you doing today?
Hey guys, very well, thank you. As you said, I'm a geotechnical engineer. I'm registered in Phoenix and Nevada. I was registered in Louisiana, but I let it go ahead and expire because I wasn't doing much work out there lately.
Okay, all right, and so you worked with Bob Brown for a number of years, right?
Yes. So I'll give you my background. I got out of college and worked geotechnical engineering firms for a few years, and then I started my own firm. I did that for about 10, 12 years, doing transportation and forensic engineering. Did a lot of work for banks like Lehman Brothers before they collapsed. And then the '08 bubble hit, and the firm, like everybody in Arizona, got hit hard. So I found a couple contracts for myself and a couple employees, and went out and started doing FEMA work, so like forensic engineering for FEMA, initially on Hurricane Gustav, but then moved over to Katrina in New Orleans. So I was in New Orleans for about 10 years doing that. And then while I was doing that, I had done work for Bob when I was doing geotechnical engineering years ago, and he was starting to build up his forensic group for his foundation company. So myself and another engineer went over, and we were doing it like a part-time work for him. I made my way to Puerto Rico and was working on the Hurricane Maria and the earthquakes in Puerto Rico, and still doing side work for Bob. And then I was ready to come home, and so Bob's main engineer was getting ready to retire, so I became a principal engineer for Bob and his firm for a couple of years before he sold it. So, I mean, that's my backstory and how I got into forensic and geotechnical engineering.
Now, let me ask you a question quick. What is forensic engineering? How would you sum that up?
I would say that's when structure's already existing and has damage, and you're trying to figure out what's causing that damage. So in the case of obviously, for the FEMA work, it was this damage storm related, or earthquake related? Can FEMA fund it? In the case of geotechnical engineering, a lot of times there's settlement and what's causing that settlement, or there's walls bowed and what's causing that wall to bow. What's causing the damage to the house? Is it soil related? Is it something else? So that's forensic engineering.
Okay. All right. Got it. And so has most of your work been focused on the residential side?
Certainly with Bob, it was almost all residential. He had set up a nice system and I think he talked a little bit about it, where he had his techs go out and collect all the data. Then as the engineer, I could just sit and look through the data that was collected and determine what was going on with the house. So yeah, a lot of residential, certainly when I was doing stuff for Bob. And then again, when I was doing straight geotechnical engineering, that was more, and this Bob alluded to this, there's kind of two ends. There's the design on the front end. So when new homes are being built and there's mass grading and all that, you bring geotechnical engineers to design the earthwork for those giant residential developments. But then on the back end, the forensic part is you bring a geotechnical engineer to figure out what's causing the soil to continue to move.
Okay. All right. Got it. And so how much work do you think you did related to home inspections? Did you ever go out after home inspectors would call stuff out?
Yeah, it's a combination. And this is true in all engineering. You have your staff that your direct engineer in charge of, your technicians and whatnot go out and kind of do the field work, so to speak. And this is true for all engineering fields. And then sometimes you have to go out and take a look yourself. But in terms of how many, God, I was with Bob for about 7 years. And I'd say in those 7 years, we did hundreds and hundreds of homes. We looked at hundreds of homes. Yeah.
Okay. All right.
I have so many questions. Reuben, you go ahead, but eventually I'll come back and I'll ask you some.
Okay. Well, yeah, I hope I'm not getting too off track with my line of questioning, but I guess mine's just kind of specific. I'd say, well, before I ask, what portion of the homes you look at had full basements versus slab? And Bob probably told us the same answer to this, but I forgot.
Yeah. So it's interesting. So in Phoenix, we generally have what you call conventional foundations, footings with a slab on grade. And then we have post-tension slabs. A lot of the newer homes, since the 90s have been gone to post-tension slabs. And then when you get up into northern Arizona, in the more mountainous areas, you have a lot of like walkout basements and crawl space homes. So I think that would probably match more with what you have. Were you in the Twin Cities in Minnesota there?
That's right.
Right. So you're on a river and you have shallow groundwater, it looks like to me. I just quickly looked at Google Earth to kind of get a feel of the geologic setting, just because I figured you'd probably want to ask me something about Minnesota.
Thank you.
Yeah. Well, I'm not, this is part of the important part of a geotechnical engineering. You really need an engineer who's familiar with the area, with the geologic setting, and to understand, how to repair and what is going on. So I did look, and I did enough work down in New Orleans that while New Orleans isn't the same, it's similar in that it's next to a river and had shallow groundwater. And so I got a feeling for what you have. But yeah, up in northern Arizona, we have a lot of walkout basements, a lot of crawl spaces, which I think are a similar condition to what you guys have there.
Okay. All right. Got it. And what portion of foundation problems do you think are attributable to poor water management outside the house?
It's interesting. I always tell people when I'm looking at things, when you watch like the unsolved murders and things, the police always look to the family first, right? They're like, oh, it's the husband. They look at the husband first, and then they look at the family. In foundation and forensic engineering, it's always water first. It's either it's getting too much water, or it's drying out too much. Basically, the moisture content isn't staying stable, or it's the fill. It's either the fill or the water. And if it's fill, it's because water got into the fill. And then on the third element, I would say, especially with homes, it's trees.
Okay.
And the trees affect the moisture as well, because they're either getting watered and causing, they're too close to the home and they're getting watered next to the home, right? Or they're sucking the water out from under the home and drying out that soil and causing a problem that way.
Okay. What about roots?
And roots too. So it's funny. We had Bob was talking to you about expansive soils, and that's a real issue here in Phoenix. When the water, because we have dry soils, right? So, and I believe, and I'm not sure, but I'm guessing Twin Cities has really wet soils next to the river. And in geotechnical terms, it's like wet of optimum or dry of optimum. So in Arizona, the soils are always going to be dry of optimum. And so when water gets into a clay soil, it wants to swell. Whereas if you're wet of optimum and a tree starts sucking the water out of a clay soil, it's going to want to shrink, right? So Bob was talking about how we were dealing with expansive soils here and his MLM system and some things like that. Well, one time we had a pretty good debate about, we had done the manometer level survey, and there was a heave in the slab, and we went round and round. And anyways, long story short, we had to tear out the slab, and there was just roots curled up all under that slab from the tree that was right outside of the wall there. So,
wow.
Yeah, roots are a very big issue. Trees are a big issue. The rule of thumb I would tell people is, when that tree is mature, you do not want the canopy of the tree hanging over the footprint of the house.
Whoa.
You want it that far away. Yeah.
Whoa. Okay.
Yikes.
All right. I've got some work to do as I look outside my window.
My stepsister has an oak tree, and she lives in California, and in touching an oak tree in California, I think it's death penalty. So, and her canopy hung over it.
I was going to say, we've had people on our show recently from California talking about just the different issues they have with fire and how they inspect a house to make sure it's safe. And I mean, that was one of the key things, is you can't have, bushes, shrubs, trees right next to the house. And now, spending more time in Florida, I look at trees too. And I think about insurance rates and people not getting approved for insurance because they've got trees that are close to their house or limbs hanging over with hurricane damage. So there's a lot of reasons why it's not good to have trees over your house, I think.
Yeah. Trees are great.
Yeah.
They just need to be far enough away.
Yeah. Well, so, okay, Michael, going back to that podcast we did with Bob Brown a while ago, I remember kind of just hearing him talking for the first time which I'm ashamed to admit this, about geotechnical engineering and what a geotechnical engineer did and why it was important to have someone with that skill level in to assess foundation issues. And, I'd say like in our industry, a lot of times as a home inspector, we do our best to, you know, evaluate the situation and determine if, the cracks or the offsets we're seeing in the foundation are cause for getting, a further opinion from an expert in the industry, or, we say, okay, monitor this crack. If it changes, then go to an expert, but do all these things in the meantime to try and reduce shifting of movement. And usually it's water related, right?
Right.
But I think, for the most part, our industry is a little uneducated about who to refer homeowners to. We used to refer them to just, regular, I guess, civil engineer, Reuben. Is that who we would direct people to?
A structural engineer, typically.
Structural engineer. So what would your advice be, Michael, to, people in this industry that are home inspectors or even a homeowner that you're seeing a foundation that has significant problems with it? Who do you go to first, and how do you find that person?
Well,
what would your advice be?
My advice would be, and I know you guys are like, as home inspectors, you're dealing with a transactional situation. Yeah. My advice to homeowners would be, before it gets to a transactional situation, like we all came home for COVID and we sat and looked at the cracks on our walls and thought, is that crack something?
Yeah.
So I think the best thing to do for the homeowners before you get to the transactional stage, figure out, is the crack moving? So let me back up a bit. When a home is built, there's 3 stages of settlement. There's the settlement that happens immediately as it's being constructed. There's a secondary settlement, or initial, what do you call it? We'll just call it an initial settlement after the initial construction. Especially with fine grain like clay soils, you'll get consolidation. And then you'll get a secondary long-term consolidation. And an extreme example of a long-term consolidation is the Leaning Tower of Pisa, which has been having long-term secondary consolidation for 500 years. So, if your house was built on all sand, then you're just going to have the initial settlement during construction. And then as long as the sand was compacted, you're not going to get a secondary or even tertiary consolidation. So that said, the first thing I would look at is like, okay, I'm sitting in a house that's 30 years old. The settlement's mostly done by that point. It should be. So if I see a crack and I start to think about it, and let's say I want to sell my house next year, I would take a picture of the crack. I would date it. I might even go around the whole house and take pictures of all the cracks that are maybe, wider than 1/8 of an inch. And the other thing I would do is I'd put that a piece of blue painter tape across it, and see if it rips open over time. Because the thing with soil movement is it's very slow. And so you put a little piece of blue tape across it, and then if it rips open, that's a good indication that it's still moving. If it doesn't rip open, then it's probably not moving, right? And you can go ahead and fill the crack and sand it and make it look nice again. And then, because I think as soon as you start bringing in, a foundation company or an engineer, well, less so with an engineer. The engineer comes and looks at it and says, yeah, I don't think you have a problem. Then you now have a kind of clean bill of health for the house. But if you bring in the foundation company and they're trying to sell you piers, now you kind of have a disclosure thing you have to think about, right? So,
and you may not even need it, right? Because they're there to sell you something, so you may not even need that repair. Yeah.
Yep. So before you bring anybody in, just, is it even moving at all? Because settlement's normal. Cracks are pretty normal for homes, so my thing would be on their own, see if it's moving or not. And then the next part is, if you have a 30-year-old home and it's still moving, you got to something caused it to move, So are you getting water somewhere? Do you need to add gutters? Do you need to add some, do you need to move the water, 10 to 15 feet away from the home.
Mm-hmm.
Grade it, or, work on your grading and drainage, and then monitor that crack some more after you've had a lot of time for that water to, the moisture content to become constant. The house will stop moving, and then those things will settle down. It's when you can't get those things under control that you then maybe have to look at a more active kind of repair. Maybe it's piers, maybe it's something else. And then the other part is, a lot of times you get just the age of the foundation. Like up in northern Arizona, again, we have 100-plus-year-old homes that are built on what's called rubble foundations. It's just stacked rock. And so it may be time to do some repointing or some things like that. But, it doesn't necessarily require the super expensive steel in the ground solution.
Sure. Mm-hmm. And let me ask you about the painter's tape. I've never made a recommendation like that before, and I remember Bob Brown talking about that. And something I've thought is came up later in my head that, wait a minute, if you got kind of a moist foundation wall and you put that blue painter's tape, is it actually going to stick well enough for the tape to tear? Is this going to be worthwhile? Maybe right. It is. If he recommended it and you're saying it, obviously there's cases where it's going to work. But what we've always said in the past is if you got these little cracks, like patch them with mortar, something that's not going to flex. Yeah. And right. Then if it does open, it's going to break open again. And the other reason I like doing it with mortar is that then if you want to paint the wall and kind of hide the crack a little bit more, it's not going to be quite so obvious.
Right.
Do you have a problem with that recommendation?
No, I would, not at all. Other than the tape is cheap and fast.
Yeah, that's a lot easier.
Yeah.
Okay.
The other thing is in Arizona in particular, you're going to get thermal expansion and things like that too. So sometimes it can just be that's causing it to, you get a little movement from thermal expansion. And then also if depending on what part of the country you're in and seasonally, you get a moisture variation in the soil and especially if you have an expansive soil. Bob and I called it it was almost like the house was breathing, because the soil will be going up and down with the moisture variation, seasonal moisture variation. So it's something else to keep in mind.
Okay.
You probably get called out to the, obviously the foundations that have issues going on and cracks that are, indicative of problems. But what would you say is like the percentage of cracks in foundations that actually do need some sort of active repair?
Well, that's an interesting question, because it's called serviceability. And so almost none of the cracks I come across are what I would call a safety issue or a collapse issue. It's really it just doesn't look good. You have a crack in your tile floor, or you have a crack in your drywall, and it's a serviceability issue. And then if the house is moving slowly and you, like we just talked about, you patch the crack and then it opens back up. Well, did it really cause a problem? Probably not, other than I have to, patch and paint this crack again. So, and then that part also leads to personal preferences. There are homeowners that don't care about the crack, and then there are homeowners that's almost like an obsession. Like they want no cracks anywhere. And so it's interesting because, we go ahead and install, piers because they were like, no, we don't want it to move at all. We're not, and so we want this to be crack free. And you're like, all right, well, that's expensive and we'll go to it. Whereas some people are like, no, it's fine. I'll deal with it, and as an aside, I was just reading, there was an article in the Wall Street Journal on the waterfall house in Illinois, the Frank Lloyd Wright house, famous and iconic here in America.
Oh, are you talking about Falling Waters? I think that
Falling
might be
Water. Yes.
Over is that Pennsylvania? Maybe, I'm not sure.
I thought it was Illinois, but anyway,
they were
Frank
Lloyd Wright house with water going through it. which is all of them.
Yeah, and it
Sorry.
was $7 million to do this rehab on it, and it's got leaks from the water.
Yeah.
And I thought, my house has a couple leaks in it itself, and I got to get a roofer out and this and that. And I was looking at it, and I'm like, well, how bad could it be? Frank Lloyd Wright's house has it,
I've been through several of his houses, and they all have little Tupperware containers out catching all the leaks.
Exactly. So, but see, so some people that matters a lot, and some people it doesn't. And it really is a serviceability issue. Now, one of the, kind of along those lines, and I'm sorry if I'm over talking here, but
no, go ahead, please.
Bob, you'd asked in the interview with Bob, like, what's the threshold? And there's the calcs, tilt and deflection, and engineers love to hang their hat on that, but it's kind of a silly thing to hang the hat. I mean, it's okay, use it as a tool, but ultimately it's a mathematical model, and we don't need a mathematical model for houses because they're already there. We have a full scale model, and it's called the house. So we can look at the tilt and deflection, but the house is telling us where it's moved. When we run the manometer survey, we can see areas that are higher and lower. But what's interesting on that even is at Arizona State, they did back in 2000, they did a study where they went out and did manometer tests of brand new slabs freshly poured for residential homes. And, none of them were flat. And on average, there was a 1/2 inch differential on the average. And the worst case one had a 1.2 inch differential. So nothing's ever poured perfectly flat to begin with. And in the big picture, it's really about what is that homeowner, what is their tolerance, for these types of things. And that's really what it comes down to. So, I got a lot of thoughts, and I got a little confused on where I was going with that. But anyway, it is a serviceability issue, and it's not very infrequently is it a safety issue. There's only been about maybe I could probably count on my hands, out of all those hundreds of houses, how many were actual like safety concern. All of them were more serviceability concern.
Okay. That's good to know.
And if it's I hear you saying, like, if it's a serviceability issue, it's not a major structural concern. You don't really have to do any major repairs, it sounds like. No,
you don't. I mean, you can patch the crack, and then if it reappears, you can patch it again. The house isn't going to fall down. The example I was going to give you also was we had a residence where it passed in tilt and deflection, but they couldn't open their front door, and it was a PT slab, and it dropped off like an inch in a very short period, a very short distance, but it still passed in tilt and deflection. And so we went ahead and had them install some piers to lift the front end of the house up. And then I got into a kind of a debate with another engineer who said, well, past tilt and deflection. And if the house continued to settle, that probably would have worked itself out. And I said, well, how many years does he have to wait till he can open his front door? And not continually trim that front door
issue.
So you can have things that are like, well, mathematically it works, but realistically, serviceability wise, it's not realistic for that homeowner to continually trim their front door, and so you might, in that case, they may want to go ahead and get some piers or something installed.
Sure.
Yeah. Going back to your, you mentioned there's kind of like 3 phases of movement. What's the window? Like, if you had to assign years to it, what's the window for kind of the initial settlement after construction? What's reasonable for a homeowner to kind of see the first crack show up, and for how long should they continue to kind of move a little bit?
Yeah. So, obviously it depends on the soil type. If it was a pure sand, like on the beach sand, then and it was compacted and everything, we'll assume all things were compacted and done properly. That would be it for the settlement, right? During construction, all the, what's called is excess pore pressure. So if you think about soil, the soil matrix, in the ground. It's the particles of soil, and then there's air, there's voids, right, with air in it, and then there's water. Okay. So, and the voids either fill up with water or fill up with particles as it consolidates, right? So, when with sand, so when you put a big load on it, the air needs to escape, right? With sand, it can escape immediately. So you don't have what's called excess pore pressure. With clay soils, it's so tight that it's hard for the air to escape. And so that's why it'll take longer for the consolidation to happen. Now, once water hits it, it facilitates that soil to move easier. And while it's reconfiguring, then it's going to settle. So in a sand soil, you're going to get the settlement should happen immediately and then not. In a clay soil, I can't remember the number, but I think it's like 90 something % should happen in the first 10 years, something like that effect. So
that's longer than I thought. Yeah.
Yeah. But that's why, like on new home construction, they'll do the repairs, for whatever 3 to 7 years after construction, something along those lines. So, then that's why, because you're going to get those movements. And that's why especially when people call me out to look at new homes, we're really apprehensive to do too much, because it's still in that phase of it's settling.
And you just say this is normal. This just happens.
Yeah, it just happens.
Yeah.
Wow.
Okay.
Unless you see something extreme,
Yeah. How would you define? I was just going to ask you, how would you define extreme? What would that look like?
Well, there was a house down in Tucson we were dealing with. It had a foot of differential.
What?
Yeah.
What?
Yeah.
I've never seen a foot.
Yeah. And it was a PT slab. It actually, are you guys still there?
Yeah.
Yeah.
Yeah. Okay. Sorry. My computer went to sleep real quick. It because it was a PT, it sort of tilted all together, but it was a foot in tilt. And, ultimately we ended up having to use piers to kind of level it all out and whatnot. But that was, I think, within 5 years of construction.
Okay.
So we were like, yeah, you got to do something. I'm trying to think of the guy with the door, that was pretty new to construction, but it was like, well, yeah, you got to push that back up. And, and it was enough that you couldn't continue, he would end up having to trim the door constantly. And that just didn't seem reasonable. On the other hand, there's been a lot of time, most of the time with newer homes, we would say, hey, we'll go out, we do the manometer reading, and then we'd come back and say, call us back out in a year and we'll reread it and see what happens. And that would be another thing I would make a point on is with all these things, you really need to observe it over time. So one manometer reading, while that's great, you can see where it seems to have moved and you can correlate that to where maybe damages are appearing on the house. It's best to have 2 readings to know is it continuing to move. And
wait, when you say 2 readings, you mean over a period of time?
Yeah, over a period of time.
Yeah. How long of a period of time?
Better.
9 months to a year.
Okay, got it. Sorry, go on.
Okay. I kind of like a year because then you're reading it at the same time. Like if you read it in December, you're rereading it in December so that you're not getting any crazy moisture variations or other temperature variations.
Yeah.
Things like that.
Yeah. Similar data points.
Yep. So, that's the thing. So and even in court cases where it's come up and we would maybe have one manometer reading, that's the first thing that the attorneys like to hit on is we only had one reading. And we're like, yeah, but look at all the damages where there were low points, that clearly was, there's times where we could deal with that with just the one reading and that's fine. But what I would tell homeowners is, and this is kind of the same thing with the blue tape or these other things, or taking pictures of the cracks to see if they're opening up. What you're doing is you're measuring this over time to see how it's moving and if it's even really moving at all. And so Yeah.
Mm-hmm.
And to that point, going back to the ASU study, nothing is poured flat. So if you get a reading and it's not flat, well, of course, because nothing's perfectly flat when they built it. So now you really want to know how it's moving. So my point is, like, just relying on a manometer survey alone wouldn't be good. Like if you had a house that wasn't passing, say, in deflection, but had no damages, and there wasn't any, and it wasn't like the foot differential or whatever, and all the doors and windows opened and the house operated normally. Well, who cares if it passed in tilt and deflection? Then it's fine. That may have resulted from the construction, when it was poured.
Sure.
Whereas you could have one that's not passing in tilt and deflection, but you see that there's a tree that's caused something, or I even had a house. There's another thing. I always look at aerial photographs to see how the vegetation and how the roof changed over time. Not just for when maybe they added some additions or whatever, but also did they change it from a asphalt shingle roof to a tile roof? And did they increase that load? And is that what's causing the cracking, as opposed to the soils? So there's a lot of things that you got to look at.
A lot of variables.
Yeah.
What kind of tools would you say you need and you use for your evaluations? Like, what's your process look like typically?
Obviously, the manometer.
Yeah. So go out, draw up the house, and it's funny because I have a couple other engineers they're wanting to kind of start up a business doing, kind of helping homeowners out with this. So we're trying out different software right now to figure out what's the easiest way to draw up that floor plan quickly. But so draw up the floor plan, run the manometer, locate all the cracks. Generally, we're not worried about second and floors that don't have foundations. Where the floor plan's mostly focused on the area where the foundation systems are. Draw up the locations where there's cracks. Look at the aerial imagery over time to see how that house has changed over time, how the landscaping has changed over time. There's the USDA has soil maps, so even if you don't collect soil samples and get them run, you can go to the USDA website and look at what the soils are for that region. In Arizona, we have a couple other soil maps that show us where soil hazards are, such as expansive soils for certain areas. So, but even without that, if I look at the soil conservation map and see a lot of clay soils, I know that has potential maybe for that area and for that house. And so, that's a pretty good overview of what we would look at. I'm sure I'm missing a couple other things, but if it's a crawl space, might see how far into the house we can get and get information from that. And then, so.
Well, I just had an interesting thought. Insurance companies already have the floodplain maps, and they won't insure you, or they'll charge a ton more if you're in a floodplain. How long is it going to be before they start using these USDA maps and they say, wait, you've got really expansive soils? It's going to cost you more in insurance
Don't
to
give
have
them
a house
that
here.
idea, Reuben.
We're deleting this portion of the podcast.
Yeah. No, it's funny. I just bought a property up on the Verde River up here where I'm going to build a house, but and it's in a floodplain, but after being in Louisiana for all those years, I'm going to, it's about 6 feet up to be out of the floodplain. I'm just going to go ahead and take it on up to 10, so that we can just park cars under it and not worry about it. So
put it on piers.
Yep.
Yeah.
Love it.
So. Wow. That's interesting to hear your initial assessment that it takes such a, I was thinking you'd be in there with a tape measure, microscopic stuff, evaluating the cracks and all that, but you're really taking a zoomed out approach as well, looking at the history of the house and the change in vegetation and landscaping and all of that and structure. And that's really cool, I think.
Right. Well, because if you think about it, if they put, if they did an addition, always cracks between the main house and the addition because they're settling at different rates,
Sure.
like
Yeah.
at different amounts.
Yeah.
Yeah. Or where if they, especially with walkout basements, you think about they dig out the basement, they build the wall, and then they backfill behind there. And that backfill always has problems, and if it's just backfill in landscaped area, nobody cares. But when that backfill, when you have like a kind of a stepped home with a backfill zone behind it, then the floor starts cracking in that area. And they're like, hey, what's going on here? And it's always the fill. So so when you look at aerials and you look at how a lot was developed, you can sometimes see that. So one time I looked at this guy was complaining about cracking in his house, and we were looking at it, and I zoomed out on the aerial, and on the other side of the hill was a giant quarry. I'm like, well, you might want to talk to them because I guess they're probably doing some blasting over there.
Wow.
And we think that maybe that had been the cause of the cracks to the house.
Oh, interesting. Yeah. I've just kind of a general question. I know the answer is going to vary depending on the type of crack and the type of soil, but if you had to kind of list the top type of repairs that you assign to most of the cracks that you see, like, is there a classification of like the most common types of repairs out there? Would you say like piers is one, and what else is out there, and what do you most commonly recommend for what you see?
Yeah, so let's start with the fill. When you have a problem with fill, you can do compaction grouting, but they also now have they have other. It's not compaction grouting, but it's like compaction grouting, but it's using polymers. They expand, so they eject them in there and then they'll expand.
I've seen that like a caulking kind of material that you push into the crack.
It turns into like foam. They use it to lift slabs sometimes. You can go on.
Okay.
That same material now. There's a couple companies that have developed ways to inject it into the soil and bring it up. A lot of DOTs or Departments of Transportation are using it to deal with some of the fill issues that they have. So that would be one. Another very common one, maybe more so in Arizona, is the stem walls, where you get the steel starts to expand from rust and cause the horizontal cracking. And so you have to chip that out and clean up the steel and then patch that. So there's a lot of that type of work. The piers, we used to drop the plans and we would actually call them like, they would be like, I can't remember the term we used, but it wasn't like, hey, we'd tell them you don't have to put these piers in. But if you're really concerned or you're trying to sell this house immediately or, and you want it just bulletproof, here's a pier plan. So you get push piers or helical piers. And where you use those types of piers really depends on a variety of things. Like sometimes you might have to put a pier under a window. And so we'd use a helical for that because the push, pushes off the bottom of the footing to get its lift. And the weight of the house, for a push pier, it's the weight of the house that's driving that pier down. Helical and push piers. Then it's something you guys are familiar with the basement. Sometimes you get the wall bowing, and they have different companies have different kind of steel beams that they use. They connect to the joists and whatnot. We used a lot of smart jacks under the crawl spaces to level floors, and those would usually use also a push pier system. So you put drive a pier down and then set the smart jack on top of it and then level the crawl space floor. I can't really say like what was more common or not common. But those were the primary things. But this is the other part. When you call a foundation company, that almost all of them have that kind of set of tools that I just went through, those kinds of solutions. But there's frequently times where we would see a retaining wall that was failing or something, and the solution would be, say, a buttress wall for that retaining wall, which would be like putting a wall in front of the wall.
Yep.
Okay, so or there would be other solutions that were better, made more sense, but because the foundation companies don't have that, they're trying to, I think you guys were calling it, if the only tool you have is a hammer, then everything's a nail. They're trying to use
the nail, yeah.
They're trying to use that hammer on everything. And, so that when you bring an engineer in, they're going to look at it and go, okay, this is probably the better type of solution for this. And then you can get the contractor that's appropriate. Just like when I was talking about the rubble foundations, you can't put a push pier on a rubble foundation. What you need to get is a true mason to come in and rebuild it old school style, and do it that way. So.
Okay. Interesting. My sister has a house like that. It was built in the 1800s, and they're actually renting it, but the landlord had some foundation repair work done right before they moved in, and it was a very interesting looking repair. They rebuilt like the top maybe quarter or third section of the wall, and it is so uneven in their house that she has a short, maybe 4-foot bookcase on an exterior kind of wall corner where they did that repair, and she had to move it because it was leaning so much. The floor has I should get my level over there. It probably is 6 inches between over about 15 feet of difference in height on the foundation. And everything just my little nephew who's 1 year old and he chases balls around, he'll throw the ball and it always rolls to the same low spot in the house.
Love it.
Yeah. And that would be a good thing. It's not just manometers. You can use zip levels as another brand that I think Home Depot sells zip levels. They're about $1,000. And then you can, anybody can use it to go measure the levelness of their floor. You just draw it up and then start setting it there and see what the differential between the two locations are. But I mean, one time we went out to look at one where a foundation company had used a set of piers. The stem wall and the pier had, in one part of the house, or the stem wall and the foundation in one part of the house, had kind of separated and tilted. And then they tried to use the push pier to push it back into place, and it didn't work, and honestly, the better solution would have been to just dig it out, brace it while you reset a new stem wall and footing in that location. I think would have been the better plan. But they went for it. It didn't work quite right. Sometimes that, you can push it back into place, but the question is, okay, when you can't, then what would you have done? And I think in that case, it would have been better for them to just, rebuild that section of the footing.
Yeah.
So, yeah.
Well, we're running short on time here, but you did say something that made me think of a question. You were talking about this one house you looked at where they had a quarry nearby, and you said they're probably doing a bunch of blasting. And it made me think, over the years, I've had a number of people contact us because, our company name is Structure Tech. So they just assume that we've got engineers on staff. And they say, well, my neighbor's doing a bunch of construction on their house. And they've had a bunch of heavy machinery over there. And, there's days where I can feel the earth moving. And now I think I've got these cracks in my wall, and I don't think they were ever there before. And I think my neighbor's construction is ruining my house. Yeah. Is that possible?
Generally for regular light residential construction, no. But possibly, like, for instance, if they were building a basement in rock and they were doing blasting, and, so one of the things when I had my own engineering company, we had to measure, when they were building light rail here in Phoenix, they were going right next to Indian ruins that were near downtown Phoenix, and trying to think what the threshold was, but it had a really tight threshold, and we had to so we had sat there with vibration monitors. But so that it's kind of an interesting thing. So like vibration monitors, when you measure those vibrations, the just because you hear it or kind of rattles the window isn't the vibration that necessarily causes the damage. So, you know, it really does take kind of a, you know, I know people think that the construction next door might be causing it, but we've done quite a bit of vibration monitoring over the years for blasting and all sorts of things. And, I would say, you know, just regular construction, probably not going to cause it. But if they're doing something that's, you know, moving, you know, like I said, blasting or things of that nature, then
how about pile driving?
Yeah, but pile driving might, yeah.
Oh,
okay. But then, you know, typically the contractor who's doing it doesn't want that headache, and they usually have monitoring going on. So,
that makes sense.
Yeah, they usually have somebody sitting with the vibration monitor between, you know, what they're doing and the nearest houses. And I think it's it's a weird unit, 2 inches per second or something like that. There's a threshold for construction that's pretty well established. So when they are monitoring, that, you know, they'll know whether they did it or not.
Okay. So it's not impossible, but it's pretty unlikely.
Yeah. Right.
Okay. All right. Got it. Well, you have been a wealth of knowledge, and you are just a chill guy. I mean, you just seem to take all this in stride. I wish you were in my area. I would love to refer you for this kind of stuff when people have got these concerns, because I think you could talk a lot of people off the ledge.
Yeah. They need it, I think, you know, and that's why I think we're getting ready to start up a little something out here to give them options, you know, because it's not cheap, you know, it's what, $3,000 per pier, basically, right? So they get a recommendation for 10 piers, and, you know, $30,000, and maybe some gutters would have solved it, you know, or you can do a lot of patching for $30,000, you know.
Sure. Yeah, absolutely. So, well, if people want to find you or reach out to you, how can they find you, Michael?
I'll give you
with a name like Michael Simpson.
It's
good luck.
Yeah, I get lost pretty easy. I'm just gonna give you my email address. It's mrsimpson45 at Yahoo, like Mr. Simpson 45.
Okay.
And if anybody wants to reach out and ask me questions, that's great. No problem.
Okay. All right. Excellent.
Yep.
Well, Michael, thank you so much for coming on the show. This has been fantastic.
Thank you.
Thanks, Michael.
For our listeners, if you got questions for us, show ideas, whatever, please email us. We read them all. It's podcast@structuretech.com. And we will catch you next time. Take care.
Take care.